A little ways back, I showed you how to draw an ionic bond where you transfer the electrons over and then you put the charges of the ions. What I'm going to show you today is how to do molecules, and we use Lewis structures. Lewis structures is kind of like we did before where you had the valence electrons around the elements. Now what you're going to do is you're going to put them together to form your molecules. Okay? So when you're drawing a Lewis structure, the most important thing you got to worry about is the valence electrons, because that's the electrons that are available to form bonds. Okay? So when you're looking at drawing a Lewis structure, you've got to take what elements you have. You've got to look them up on your chart and figure out how many valence electrons they have. Then you put them together in a way that everybody has 8 electrons around them. Now, they might have to share 2, 4, even 6 to do that. Or, except for hydrogen. Remember, hydrogen only needs 2. Everybody else needs 8. So you got to situate those electrons. Now, if you're doing a metal and a nonmetal, you don't write Lewis structures because they don't form molecules, they form ions. So this is only going to be when you have nonmetals, okay? All right, so you draw a skeleton arrangement of the atoms, and again, connecting them with single bonds to see if you can get them to have 8, okay? So, and again, I'm going to show you how to do this, and I'll also, when I'm done with this, I'll do the little model with my hands, okay? All right, so you subtract the number of bonding electrons from the total available, and again, I'll show you how to do this too. For instance, if you have 3 elements, you have carbon and 2 oxygen, okay? You're going to do CO2. Carbon has 4 valence electrons and oxygen has 6. So altogether, you have 4, 10, 16. 12 from the oxygen and 4 from the carbon. So you have 16. Now they each need 8. So if you have 3 molecules, 8 times 3 would be 24. So 24 minus what you actually have, 16, would mean 8. That means you're going to have to share 8 electrons. Okay? And that's how you figure out your electron pairs. So when you have double bonds and triple bonds, I'll show you how to do this, and it helps it when you're trying to figure out how to draw their Lewis structures. Okay? Most of the time it's single bonds, you guys, but you have to have double and triple sometimes to make a complete molecule, because again, everybody needs 8. You need octets. That's what they're called. 8. 8 electrons is an octet. Okay. And again, sometimes you have to form double bonds and triple bonds in order to do that. Okay. So, I'll show you a numbers way of doing that. And sometimes you can just visually do it. I never had a trouble with it. I could always figure it out. But again, I'll show you an easier way with the numbers to help you if you need to do double and triple bonds. Okay. So draw the Lewis structure for NF3. So we have nitrogen, and we have 3 fluorine, okay? So if you want to do the valence electrons, okay, nitrogen has 5. It's in the 5th group, it has 5. And then we have fluorine, we have 3 of them, and they have 7. So we have 21 plus 5, we have 26 valence electrons total, okay? Now, the other thing we look at, we have nitrogen and fluorine, so there's 4 molecules altogether, 1 nitrogen, 3 fluorine. They all need 8. So 8 times 4 is 32. Okay? So if I take 32 minus 26, that's 6. That means they have to share 6 electrons. That's 3 bonds. Okay? All right, so I arrange them. So I put nitrogen and then the 3 fluorine around it. And you guys, I'm going to use dots just because then you can keep track of every electron. Because they're missing, like nitrogen has 5. So I'd have 2 up here, and I'd have 1 here, 1 here, and 1 here. Then I'd put the fluorine around it, and then actually I'd be done. Okay? And again, like I was saying, subtracting the numbers. Okay? This is how it would end up. Okay, nitrogen has 5. So 2 here, 1 here, 1 here, and 1 here. Fluorine has 7. So it just needs 1 more. So if it shares up here, and again, I'm going to do dots. I think dashes sometimes confuse people. I know this means 2, but I'm going to do dots so that you can see where they all come from. But this structure, NF3, is going to have 1 from fluorine and 1 from nitrogen. 1 from fluorine, 1 from nitrogen, 1 from fluorine, 1 from nitrogen. Now, if you count, nitrogen has 2, 4, 6, 8. Fluorine has 2, 4, 6, 8. All of them have 8. So everybody's good. So this would be the Lewis structure. This would be the molecule of nitrogen. And when you have a formula, the one written first, unless it's hydrogen, is the one that goes in the middle. That's the central atom. And then you just put everything around it and situate it so that you have 8. Okay, CH2O. Again, carbon's going to be in the middle. Okay, number wise, you know what? I'll show you the number thing later because it might get too confusing for you. Okay, so I'm going to put carbon in the middle, and I have 2 hydrogen, and I have an oxygen. Okay, now carbon has 4, oxygen has 6, and each hydrogen has 1. That's this number right here. 4, and then there's 2 hydrogen and 6 from the oxygen. So we have 12 altogether. Okay, but how many do we need? Well, I need 8 for this carbon. Each one of the hydrogen need 2, so that'd be 2, 4, and 8. There's 12, plus, oxygen would be another 8. So we have 8, 16, 18, we need 20 altogether. We have 12. So 20 minus 12 would give us 8. So we have 3 bonds here. I'm going to have to make a double bond here. Okay, I can't make a double bond with hydrogen. So I'm going to have to share 4 here. It's the only way that I'm going to have enough. So again, what you do to get an octet, here's the 2 from the oxygen. They're lone ones. And then they have 1 here. That now oxygen only has 6. And hydrogen only has 6 because 2, 4, 6. So we're going to have a double bond here. And now if you look, okay, 2, 4, 6, 8 for carbon, 2, 4, 6, 8 for oxygen, 2 for hydrogen, 2 for hydrogen. Remember, hydrogen only needs 2. And that way, by forming one double bond, I have a complete octet for everybody. Okay, for carbon monoxide, okay, carbon has 4 and oxygen has 6. That's 10. All right, they need, each of them need 8. That's 16. So 16 minus 10 is 6. Now there's no central molecule here because there's only 2. When you only have 2, there's no central. They just form like a linear bond. But I need 16. Each of them need 8. And I only have 4 here and 6 here. That's 10. So 6, they have to share 6. That means I have to form a triple bond. 10 is what I have. 16 is what I need. And again, I get the 16 because this one needs 8 and this one needs 8. So if I subtract 16 from 10, I get 6. It's going to have to be a triple bond. Okay? Still not there because look, 2, 4, 6, 2, 4, 6. If I move them in, now if you look, these 2 are from carbon and then it shares 2 more here. And then the oxygen shares 4. So we got 2, 4, 6, 8, 2, 4, 6, 8. So the only way that carbon monoxide can be stable is if they share 6 electrons. That's a triple bond. Okay. There are molecules that have single structures. Okay, here's the Lewis structure. When it says a -2 here, you guys, or negative, this means I get to add 1 electron. So if we're doing polyatomic ions, if there's a -2 up here, you get to add 2 electrons. If there's a -3, you get to add 3 electrons. Okay, in this case, there's just 1 negative, so I get to add 1 more electron when I'm done. Okay, so when I draw it out, let's see, let's do it. Okay, this is what it looks like. All right, I have nitrogen and I have oxygen on both sides. Wait, is that all the way down? There we go. Okay, so in order for it to be stable, again, I have 18 electrons. I have 5 from nitrogen and I have 2 oxygen. Each oxygen is 6, so that's 12. And then that 1 extra up there, that's the one here. So I have 18 electrons that are available. Okay, each of them need 8. So 8 times 3, 24. I need 8, 8, and 8. That's 24. So 24 minus 8 would give me 6. That's why I know I have to have 1 double bond and 1 single bond, because there's the 6 that I'm sharing. Okay, so this is oxygen 2, 4, 6, 8, nitrogen 2, 4, 6, 8, and this oxygen 2, 4, 6, 8, 10. We got to get rid of one of those. Oh, they didn't do that. This should only have, this should be 1 less. Sorry about that, you guys. I didn't do that. This is from the book, okay? Because 2, 4, 6, 8, 10, it can't have 10. Okay, it can only have 8. So there's 1 extra pair here that shouldn't be here. They forgot to move it in the middle. Okay, but when you look here, okay, well, which side does the double bond go on? I mean, I've got it over here and I've got it over here. Either side, it doesn't matter. But when you switch the sides like this, okay, when you have a double bond on one side and a single bond on the other side, these two are called resonance structures. Okay, they represent the same compound, but because you move the double bond around, they actually are a little bit different in the way they react. Okay, I know it seems kind of weird, doesn't it? But these are called resonance structures because you have a double bond and a single bond, and a single bond and a double bond. So when you move that bond around, those are called resonance structures. And there's some sulfur, SO2 does that. There's some that do that. Sometimes you just have a double bond on both sides and then they wouldn't be resonance structures. But a resonance structure means you have, you move the bonds around. Okay? And again, that's the only way. See, they still didn't take it off, or did they? Yeah, here they did. See how they took it off here, but they didn't take it off here. And I'm sorry about that, but I don't know what happened. But again, it's the book. It wasn't me. I didn't make the mistake. I make plenty of mistakes, but this time it wasn't my fault. Okay, if we're going to do CO3, which is carbonate. Okay. All right, so we're going to put carbon in the middle with its 4. We have 3 oxygen, so that's going to be 18, and then plus 2 electrons. Okay. So we get to add 2, and so then when we're done with our structure, we get to put a -2 sign because we had to add 2 electrons in it. So we have 24, but we need 3, 4. We need 32. 8 times 4 is 32. So that's 8. We're going to have to form 4 bonds. So we put our carbon like that. And because we need to get 4 bonds, we're missing one. What we're going to do is we're going to make 1 double bond. Okay. And again, I added this up. I get 24. This is what I have available. I need 32. This guy needs 8. This guy needs 8. This guy needs 8. This guy needs 8. That's 32. So 32 minus 24 gives me 8. So that's why I know I need to form 4 bonds. And since there's only 3 things to bond to, one of them is going to have to be a double bond. And again, if you look, carbon has 2, 4, 6, 8. All the oxygen have 8 as well. So that's how you make it. Now I could move the double bond here and I could move the double bond here. Those would all be resonance structures of each other. Okay? That's Lewis structures. And again, I'd have to put a -2 up here because I had to throw in 2 electrons to make this stable. So this is a polyatomic ion, and the -2 is you get to throw in 2 extra electrons. Okay, and again, here's all the resonance structures. I can have the double bond here, here, or here. So these are all resonance structures of each other. I'm just moving the double bond around. You can only have resonance structures when you have one double bond or like 1 triple bond. I don't see it a lot with triple bonds. I should say double bonds, okay? All right. So, we'll quit right here. We're almost done with this chapter. I know this is a long chapter, but now we'll draw these structures, and then the end of the chapter talks about how we figure out their shape. And actually, that's really simple, okay? But anyway, right now we'll finish with this, and then we got one more part left.